In this paper, we introduce a novel framework called Text2Reward that addresses the challenge of reward shaping and reinforcement learning, RL. Reward shaping involves designing reward functions that guide an agent towards desired behaviors more efficiently. Traditionally, this process has been time-consuming and suboptimal, relying on manual design based on expert intuition. Inverse reinforcement learning, IRL, and preference learning have emerged as potential solutions, but they still require considerable human effort or data collection. Text2Reward takes a different approach by generating dense reward code based on goal descriptions. Given an RL goal, Text2Reward uses large language models, LLMs, to generate dense reward code. This code is then used by an RL algorithm to train a policy. Unlike previous work that focused on sparse reward code, our dense reward code has a wider coverage of tasks and can utilize established coding packages. One challenge in RL training is the sensitivity of the policy and the ambiguity of language, which can lead to the policy failing to achieve the goal or achieving it in unintended ways. Text2Reward addresses this problem by executing the learned policy in the environment and requesting human feedback. The reward is then refined based on this feedback. We conducted experiments on robotics manipulation benchmarks and locomotion environments to evaluate the effectiveness of Text2Reward. In manipulation tasks, policies trained with our generated reward code achieved comparable or better success rates and convergence speed than reward code tuned by human experts. For locomotion, Text2Reward learned novel locomotion behaviors with high success rates. We also demonstrated that the policy trained in the simulator can be deployed on a real robot with iterative human feedback. The core of Text2Reward involves zero-shot and few-shot dense reward generation. The framework takes as input a goal instruction and a description of the environment and generates a dense reward function. The instruction is a natural language sentence that describes the desired behavior. The environment description provides information about the configuration of robots and objects and what functions can be called. To facilitate code generation, we provide background knowledge in the form of relevant functions and usage examples. We also utilize few-shot examples, where pairs of instructions and verified reward codes are used to train the model. This helps the model solve tasks and generate accurate reward code. To reduce errors in the generated reward code, we execute the code in an interpreter and use the feedback to refine the code. This iterative process helps rectify errors and improve the accuracy of the reward code. Text2Reward also actively seeks human feedback to improve the generated reward functions. After each RL training cycle, users are provided with videos of task execution and asked for insights and feedback. This feedback is integrated into subsequent prompts to generate more refined and efficient reward functions. This approach allows for the participation of general users, democratizing the optimization of system functionality through natural language instructions. In summary, Text2Reward is a framework that generates generalizable and interpretable dense reward code for RL tasks. It addresses the challenges of reward shaping by leveraging large language models and human feedback. Our experiments demonstrate the effectiveness of Text2Reward in various tasks and environments. We hope that this work inspires further exploration in the intersection of reinforcement learning and code generation.